So the fib that we have here is a Quanta 3D fib, formerly made by FEI, but now they're owned by Thermo Fisher. So a lot of the instruments are very similar. The only differences you're gonna see is really the working distance that they work at, and also the angles between the ion beam and the electron beam. Different companies tend to patent those so that they basically can't be reproduced by the competitors. Okay. So let me show you the interface a little bit. The first thing is if we go to this one right here, this is going to be all these tabs here control different areas. This is our beams tab. So that's going to control the beam, basically the beam shift, stigmation. The next one is your stage. So that's going to adjust your height, tilt, rotation. The next one is your patterning. So this is what will be used to actually remove the material or tell it where we want to remove the material and how we want it to remove. And then we also have another one here that's basically our annotation. So we can draw lines and take measurements. This upper left quadrant here, this is going to be our SEM image. This right quadrant here is going to be our ion image. And then this lower right quadrant here, that's the infrared camera that you're seeing that shows the chamber, okay? So first thing to do as we start up, if you notice, we have a field emission SEM on here. So if you notice, this bar is green, which means that the filament is on and running. It's just that this beam is blanked. So it's basically separated from the column, from the chamber. If I click now on the ion beam, you can see that it's not green. So the first thing we have to do, once we make sure that we have a good pressure here, and the pressure that we wait for is usually below 5 to the negative 5. I'm sorry, yeah, 5 to the negative 5. That's when we can start. So the first thing we're gonna do is we're going to wake up the system. And once I wake up the system, you'll see that it's going to start heating up the gallium. So if some of you were at Fred's introduction this morning, you know that we have a very finite supply of gallium on here, so we don't want the gallium running at all times. So basically we turn it on when we start our session and turn it off when we're done. The next thing I'm gonna do is I'm gonna go to the patterning page, and I'm going to go to the platinum deposition, and I'm gonna double click that. See where it says cold? I'm gonna double click that to make it warm. Okay, so that's gonna warm up the platinum. So it'll take a while. And in the meantime, while all this is getting done, we're gonna actually find our area to focus on. So what you're seeing on the screen right now for the SEM and the ion, that's the latent image from the last person that was on here. They were doing some patterning. So the last image they took is up on the screen. So I'm gonna go ahead and I'm going to unpause the beam. Okay, and I'm gonna zoom out. And I usually start at 5 kV. The sample that we're gonna be doing today is some type of coating that's on a piece of silicon. What I have in the system right now is this holder that you can get from Ted Pella. And what you can see on this holder is that you have the grid that's being held vertically here, and then you have your samples that are being stored right here. You also have two sets of positions, so you can put 2 grids in and then 2 sets of samples. Okay, so if you're doing a lot of fib, I highly recommend getting one of these holders. They're expensive. They're about, I know this one's 1,000. I think the last time I checked, they've probably gone up to like 1,400, but I highly recommend them. And you'll see why, because they'll allow us to do something that basically makes the whole process a little bit quicker. So the first thing I'm gonna do is I'm going to find a feature on the surface here, and I'm gonna go ahead and focus. Okay, so I've got this little feature here, I'm gonna focus. And if you notice, I'm gonna go to my stage page. You see the Z height here, it's got this red arrow, and I've also got this little question mark here. The instrument at this point doesn't know how high your sample is, okay? So what I'm gonna do is I focused on the surface here. It says my working distance is 27.7. So now I'm going to link the stage, and now that transfers the measurement over to the Z stage, over to the instrument here. So now the instrument knows that I focused at the top of my sample and that it's 27.7 millimeters away from the bottom of the pole piece. So now I'm gonna move it up slowly. I'm gonna go to 15 millimeters. I'm just gonna type in 15 here and hit enter. And you're gonna see the sample go up. And what I'm gonna do is I'm going to refocus. Okay, and I'm gonna link the stage again. You can see now there's this little red circle around this. And what that means is that there's been such a large movement in the stage that it wants me to kind of relink the stage. And you can see there's a little bit of disparity between the measurement on the Z and what's on the screen here. Working distance here is now 14.8 and this is 14.99. So I'm going to relink and it adjusted it back. So now I'm gonna go to 10. So what we're trying to find is the eucentric position. And in this instrument, the eucentric position is at 10 millimeters. It's gonna be very close to 10 millimeters. Like I said, other instruments are going to be slightly different. Each manufacturer has its own registered and working distance. So I'm going to find a feature that I can clearly identify at about 2,500 or 2,000 in magnification, okay? I'll use this thing again. It's nice and clear. I'm gonna use this top part right here. And what I'm gonna do is I'm going to tilt the sample 15 degrees. Then hit enter, and you're gonna see the area move away. So now what I'm gonna do is physically, I'm gonna go to the stage here. I'm going to raise the Z to get that feature back into position. And then we're gonna go back down to 0. Now again, I'm going to refocus and relink my stage, okay? Now I'm gonna go up to 25. And you shouldn't see that much of a shift right now. Usually that first one is good enough. Okay, if there was a big shift, I'd readjust it again, go back to 0, refocus, and relink the stage. What I'm gonna do is I'm gonna go straight up to 52 degrees, which makes this sample perpendicular to the ion beam. Okay, again, I'm just gonna make a slight little adjustment here. And then I'm gonna go back down to 0. Now the one trick, I don't know if people are new to a fib, but the one thing with fib is anytime you turn on the ion beam, you're removing material. So the trick is to make sure that you protect your sample before you turn on the ion beam, particularly if you're looking at layers on the surface like we're doing on this sample. So some people plate the sample with gold palladium or gold. The problem with gold palladium and gold is that a lot of times that they leave islands on the surface. They do protect, but they kind of leave islands that later on when you do final thinning, you get what's called curtaining effects. So you get these kind of streaks in your sample. So what I like to do is I like to deposit a very thin layer of platinum with the electron beam and then followed by the ion beam. You don't want to go directly to the ion beam because there's always going to be a slight delay between the gas getting to the sample and the ion beam running over the sample. So you might actually damage the surface. So what I'm going to do is I'm going to find an area of interest somewhere around here. And for electron beam deposition, I want to be at a very high current. So I'm going to change my current here. What I have to do is I have to come over and go to analytical. And I want about 8 nanoamps of current. Let's give ourselves a little bit of contrast there. Okay, this sample is very dirty. Like I said, I just plucked it out from somewhere. So now what we're going to do is we're going to deposit some platinum on the surface. So I want my rectangle pattern. I'm gonna drag it across here. And then I'm gonna look for the application that says Platinum Deposition 5 kV 8 nanometers. Okay, so that's pretty large, and you can see what's happening. It says it's gonna take about 50 minutes. Well, to deposit 1 micron. I don't need it that big. So we're just gonna do a 15 micron in the X. We're gonna do 4 microns in the Y. And the Z, again, I only need to protect the sample long enough. When I turn on the ion beam, it's not going to damage the sample underneath. So all I need is about 200 nanometers. Okay, so that's gonna just be 2 minutes, all right? So what I'm gonna do, and I'm gonna zoom out so you can see this. I'm gonna insert our platinum needle. Okay, so our platinum needle is set to be 500 microns above the sample. I want to see how it comes in. And we're gonna go ahead and pause the screen here. And what I'm gonna do before, you run the pattern by just pushing this little run button up here. The problem is, if I did that right now, there'd be a lag between the time that the gas comes out and then the electron beam is running over the sample. So what I wanna do is I'm going to double click where it says closed here to make it open. And I'm gonna look at the pressure down here. I want this pressure to be up into the -5 range, or at least 9 to the -6, okay? And so now I know that I've got some flow coming through. So now I can just go ahead and start. Okay, and you'll be able to see the deposition. So right now the electron beam is only going over that small area. And I'll go over the, make that bigger. And it's depositing platinum. And you can kind of see that there's a little edge coming up on the right-hand side here. You do tend to get a little bit of drift with the electron beam. If you do that, you could always use your shifts to get it back. Is there any questions so far? I know probably a lot of people aren't doing electron deposition first, but like I said, this is something that I've done to get away from doing the gold palladium. And that really helps out with the curtaining. So if you guys are getting a lot of curtaining effects, give this a try. You saw it only takes 2 minutes. It's about the same amount of time that it takes over on the sputter coater. We're done. All right, so now I'm gonna delete that pattern, and I'm just gonna go ahead and scan. And you can see we got this nice deposition here that we'll be able to use. If you, I don't know if other manufacturers do this, but if you notice, with this system, since I have a needle inserted into the system, it's not gonna let me tilt, rotate, or do a lot of the automated type of features. I can still do X, Y, and Z, but that's just a good way to make sure that you don't crash the tip. So what we're gonna do is take out the platinum needle. And once it's out, I'm gonna tilt back to the ion beam. And throughout this process now, if I go back, see my ion beam is up and running and everything's okay. One thing that I do want to check is with this system, you can either couple the magnification or decouple. Basically, if I couple the magnification, whatever magnification I have here on the electron beam will then be transferred over to the ion. And that's what we want because we want to be in the same position. So now I'm going to come over here to the ion beam, and on our currents here, okay, like I said, anytime you turn on the ion beam, you are removing material, okay? So the current depends on how much you remove at one time. So what we typically do is we have 10, 30, and 50 picoamps. That's what we call our imaging currents. So when we first turn on the system, we use a very light current just to get a feel for where we're at. So I'm just gonna go ahead, 10 picoamps, turn it on, adjust, and you can see that I'm a little bit off. Let's check, everything's okay. I'm gonna bring that to the center, pause, and then my beam shifts were off here, so I'm going to re-zero that. And I'm going to physically raise this up a little bit with my Z. okay? And then shift it over with the electronic shift to just get that to the center. Okay, so now they're pretty much right in sync with one another. So the next thing I want to do is I want to deposit a thicker layer of platinum, because that's going to be my protection. All right, and once the platinum is used up, I can't use any more. I basically have to stop because I'm interested at the very top layer and I don't want to damage that. So we're going to add 2 microns of material. And now for, let's get rid of that. We're going to use rectangle. We're going to deposit now with the ion beam. Again, this is going to be 15. X is only going to be 2. And then Z is going to be 2 microns. Okay. So it's going to take 3 hours and 25 minutes. Okay. That's because it's basing this calculation on the current that I have. Right. So we're going to deposit at 0.5 nanometers. Okay. So that's better. It's 4 minutes. So I'm going to go ahead and take a snapshot. Okay, and what I want to do with the ion beam is I want to make sure it's stigmated really well. The problem is I really don't have much of a feature on here. Okay, this is a very flat featureless surface. So what I'm going to do is I'm going to create my own feature. So I'm going to go to the scan and I'm going to go to spot. And I'm just going to create a little spot here. So this is my beam blanker up here. I'm going to just do 10 seconds or 10 Mississippis, and then basically blank the beam again. Go back to full frame, reduce scan. And you can see I've made a little dot, a little feature on the surface, and I can use that now to focus and stigmate. I'm gonna make this a little bit bigger, make sure my stigmation's okay, focus is okay. And this is well away from the area of interest, okay? Pause there. Snapshot. Okay. All right. So once again, I'm going to insert my platinum needle. I don't have to worry about it hitting because I know that I'm at my eccentric position. So now that I've inserted the needle, I want to take a snapshot again to make sure I haven't shifted too much. I'm going to move this over so it's right on top of that area. And next thing I'm going to do is, like I did before, I'm going to deposit. So I want to open up the flow first. Make sure that my chamber pressure goes up. And once I'm in the -5 range, or yeah, I'll go ahead and start. All right, and then there is my deposition over there, okay? So it looks good, okay? So now the next task is to remove material from both sides of this platinum deposition and basically make a thin window, okay? So to do that, I'm gonna start off at 7 nanometers. Okay, again, I'm going to come down here and use this little hole here that I've created to focus and stigmate. And you can see the stigmation in there. Try and get that out. All right, much better. Okay. Snapshot. Okay. So for removal, what I'm going to do is I'm going to use a cleaning cross section. Okay. I'm going to set that up. I'm also going to draw a measurement here. I want to be about 2 microns away. Okay, because again, this platinum is all I have. All right, and what happens is if I get too close with this very large beam, the beam tails are going to start to erode away some of the platinum. So what I want to do is be about 2 microns away. For my pattern, I'm going to be using what's called silicon very high current. And when I say very high current, I'm basically using the fact that I've got some very big beam tails to give myself a very large overlap or negative overlap. So you can see here it's minus 50%. So we're not very close. Once the beam hits, it actually moves over the distance of the beam diameter plus 50% of that, okay? So what that does is actually speeds things up a little bit. I'm gonna make the width 25 and the Y is going to be at least 12. And then my Z is only going to be 1 micron, okay? And what you're gonna see is I'm gonna run this twice, all right? So I'm gonna center that up. What does that say, 2 minutes? Okay, so 2 minutes. I'm gonna center that up and I'm going to run that. Okay, so I'm gonna end up running this twice. And what that's gonna do, it's gonna dig a very deep hole very quickly. Now I told it to just do 1 micron, but if you were at Fred's introduction to FIB this morning, you'll realize that when you do a clean cross section, what you're doing is you're creating an edge. You can see how the beam is going from the bottom to the top. So what you're doing is you're creating this edge and you get an enhanced removal at the very edge. So what we'll do here is we'll set this up so that let's say every 10 intervals, we'll take a snapshot. And you'll be able to see how it advances. And what I'll do is I'll use this here. Okay, so here's you're seeing the line. Basically, it's starting back here and it's advancing towards the sample here. Okay, these little triangular things here on the side here, that's redeposition. So that's material that was removed from the face here and it's getting redeposited on the back. So now what we're gonna do is what we did on the front side, we're gonna actually have to do on the back side. So I'm gonna grab this, I'm going to change this. Instead of going from bottom to top, we're gonna go top to bottom. Now the Y on this back side has to be, or the top side, it has to be 25 microns, okay? And that's just so that, that's where the ion beam comes in for the undercut. So what I'm gonna do then is I'm going to move this measurement here. Now I wanna do it from, not from where I deposited the electron beam platinum, but with the ion beam platinum, so right there. So then I'm gonna move this over, line it up. I'm gonna hit Control-C, Control-V, and line right up on top of it again. Okay, so basically it's just gonna run twice, just like we did on the first one. And I'm just gonna go ahead and hit start, and that's gonna take 9 minutes. So now the next step is we're going to do our final approach up to the platinum. And we're going to do that at 3 nanoamps. So I'm going to come over here, switch to 3 nanoamps. And again, I'm going to refocus. I can use some of this area here. So I can use some of these features here to focus in on. Focus and stigmate. A lot of focusing and stigmating since you're constantly changing your apertures on the ion beam. Okay. So the other thing I'm going to do here is I'm going to tilt plus and minus 4 degrees. Okay. And if I do minus 4 degrees, it's on the top side. So I'm going to do 48 degrees. And I'm going to take my snapshot. Okay. So if I come over here to my patterns, I only need one pattern for now. You can see it's going to take 31 minutes. Okay. I do not have to do the entire pattern. Okay. So let me adjust this a little bit more. What I want to do is I'm going to come up right up to the platinum. Okay. I don't have to be at 25. I'm just going to change that to 20. So that's going to improve my time a little bit also. And I don't have to go this far back. Okay. That's all cleared out. I just have to go back down here. This is kind of the wall that I'm looking at. And I want to make sure that that gets cleared out. Okay. So I don't have to go all the way back. I just have to go up to here. Right. And I think you're seeing this contrast change here. I think that's the coding that's on here. But you see this little line on the back here. Let me see if that's I can make that a bit clearer. So see that line in the back there? That's pretty much where you want to go. That's kind of where your line is. And that's going to take 6 minutes. Snapshot, make sure everything's okay. And we'll go ahead and run that. Okay. Any questions there? So the reason that I tilt plus or minus 4 degrees is that as you mill this, instead of having parallel sides, because you have some redeposition going on, you tend to get a taper at the bottom. Okay, so that makes this kind of like a trapezoid, and it makes it very thick at the bottom. So if we didn't tilt it and we go to cut it away, we're actually cutting away more than, we're gonna try and get this section out to be about 2 microns or 1.5 microns thick. But then the bottom would be much thicker. And that tends to make it difficult to do the cutout on the bottom. So what we're doing is we're gonna compensate for that fact that we're getting this trapezoid by going plus or minus 4 degrees. And we'll make the sides just a little bit more parallel. Now I'm gonna get rid of this. Don't need that anymore. So now I'm gonna go and tilt to plus 4, so that's gonna be 56. I'm gonna go to my pattern, and this is where I change the scan direction. I wanna go bottom to top. So see how that is a little bit thicker line here. That tells me that's where the deepest section is gonna be. I'm gonna take a snapshot and I'm going to do my placement. Okay, so I want to be right in here. And again, let me just adjust my contrast and bring this a bit. Okay, so I'm going to center this up. And I'm going to go ahead and start. Okay, 4 minutes there. And then the next one will probably be a little bit less than that. So in 2 weeks, we will probably do this again. So Fred will actually do his applications webinar in the morning, and in the afternoon, I will do the final thinning. Okay, so be on the lookout for that. Like I said, any questions? If you want. If you attended Fred's FIB introduction, you can make sure that you email him to get some of the slides if you want. We're recording this. I will try to post this up probably within the next couple of days or so and send everyone the link. Just make sure that you email us to let us know. Email me, rgarcia@ncsu.edu, to make sure that you get a link to the video. We're gonna put this probably on our AIF YouTube page. Yeah, and Fritz TV. And I promise it's not gonna be all this long. I'll edit it in Adobe Premiere, and we'll do a lot of speed ups. All right, so now what I'm gonna do is I'm going to pause the electron beam, and I'm very used to this system, and you'll probably get used to your system. So what I'm gonna do now is I'm just going to unpause the ion beam very quickly, and I'm going to just go ahead and do a manual Z adjustment on the stage here. And I know that it's going to be about a half a turn counterclockwise. So I'm just going to do this, go counterclockwise, there you go, and pause. All right? Okay, so now you see, like I said, this is excessive. Here's our layer, but see how far down we went? And that's one of the reasons you do 25 microns on the back. Now, if we had a bulk sample or something a little bit thicker that we wanted to get, we can actually cut down here if we wanted to. So now what I'm gonna do is I'm gonna go ahead and do my cutaway. So I'm gonna do that at 3 nanoamps. So I'm going to insert my platinum needle. And then I'm also going to insert the Omni probe. Now, when I insert the Omni probe, it comes in at what's called the park position. Okay, so it's far away. So I don't have to worry about it hitting my sample. So now what I'm going to do is I'm going to move it to what's called the eucentric high. So it's basically going to go to the eucentric position at a fairly fast rate, but it's actually going to be a little bit higher than where it's at. Okay, so the Z is going to be a little bit higher. Okay, so now I'm going to move the needle to the exact eucentric position, but my sample's at the eucentric position. So what I'm going to do is I'm going to go to the manual Z over here and do a half turn counterclockwise to move it away. Now I'm going to go to the eucentric with the needle. And you should see it should come into focus a little bit better because it's going to be very close to the same height. Here you go. And it's a little bit off. It tends to go a little bit out of the way. So I'm going to move it over. And the way this needle works is it interfaces with another PC, and I can adjust the X and Y and the Z and everything. So I want to make it so that it comes over at about 2000 and it just is on the edge of the sample. Now I'm going to come over here, and now I want to be at my imaging current. Okay, so we're going to do something like 30 picoamps. Just my contrast. And there's the top of my sample there. I'm going to move that out slowly. And you're not seeing my needle. Okay, so what it is that the Z is a little bit out. So I'm going to bring it down. Okay, till it's in the center, and then I'm going to slowly bring up my section until it touches. Okay. So the ion beam gives me some perspective so I can see how far up it is. And just before I hit, I'm going to align it once again with the X and Y on the electron beam. Okay, now this is 6 of one, half dozen of the other. I like to use the X and Y controls on the stage here, and I'll adjust it so that it's, you know, right next to it and it's going to touch. You can also use the controls on the computer to move X and Y and Z down, but I prefer to do it all manually, and it really doesn't make any difference. Whatever you think is quicker. Now I'm just going to bring up the Z until it touches. And when I touch, you notice you get those little striations. Okay, that lets you know you've touched. And now what I'm going to do is I'm going to deposit, connect this needle here with a 0.5 nanoamp beam. I'm just going to do a quick focus on the needle itself. That's good. Take a snapshot. Okay, and then I'm going to deposit a rectangle right here. Okay, and it only has to be 1 micron thick, and it's platinum deposition. Okay, so it's green, and I don't want to deposit it over this section here, right? It should be at the very edge of the sample, because otherwise you could reattach it to the main sample again. So I'm going to make sure that it overlaps on the sample and the needle. Again, before I start anything, I'm going to go ahead and open the flow, make sure I've got good flow. So this is going to jump up to the -5 or 9 to the -6. Okay, and then I'm going to go ahead and start. And once I start, I'm going to check it also. I'm going to adjust my contrast down and make sure that I'm hitting both the needle and the sample. So I've noticed that sometimes it tends to move a little bit off from where I've got it. So I'm just using my beam shifts to get that over it again, to line it up. Okay. I'm gonna hide my section. I'm gonna take a snapshot, make sure I've got good connection. I've got good deposition, really good. I'm gonna delete my section there. And I'm gonna go to my reduced area section. Reduced area. And I'm just going to make it right here to cut that away. So what I'm waiting for is I'm waiting for the chamber pressure to recover. So if I had tried to remove there while it's too high, I'd actually deposit it. So now I can just go ahead and unpause. And to get this out of here really quick, I'm just gonna go up to 3 nanoamps. Okay, I'm just gonna cut that away really quick. No patterns or anything like that, it's just a reduced scan. And I'm waiting for that just to finish up and remove. And then I'll just take a snapshot over here and make sure everything's okay. And you can see it's cut away, so I can come over here and just stop, okay? And just as a precaution, I'm gonna go back to my imaging current so I don't blow away my sample. So I said that I had this special holder that I got from Ted Pella. This is the nice part of using this holder. So what I'm gonna do now is I'm going to rotate my Z height counterclockwise to move my sample away. So you see the section's still there, and I'm just gonna move my sample away. If you look here, let's make that, okay, this is where my sample's at. My grid is over here, all right? Okay, I'm sorry. So my sample's over here, it's moved far away, and then my grids are over here, a little bit sitting lower than the sample itself, all right? So what I'm gonna do is, since my sample's flat, I'm just gonna go and move right over to where the grid is, okay? So my grid's a little bit at an angle, so I'm gonna use the rotation here. I'm gonna have to do this manually because if you go to the stage page, you can see the rotation is blocked out. So I'm just gonna do the rotation manually to make sure that it's nice and parallel. Okay. So I've got the 3-post grid in here. So this is a V-notch post and another V-notch. So now what I have to do is I have to raise up the grid so that it's at the height close to the eucentric. What I'm gonna do is I'm gonna move my needle to the eucentric high position to get it kind of out of the way. So my sample's gonna move a little bit higher. And now what I'm gonna do is I'm gonna go to the ion beam. So I'm at my imaging current. Change my contrast. Now my sample's not in the field of view, so I'm not damaging it. If I move out, you can see, well, it's actually still not there, so it's well out of the way, so I don't have to worry about it. So now what I'm gonna do is just gonna bring up my Z manually. And there's the edge of where the grid should be, so it should be coming up soon, and there's my grid, okay? So I'm gonna move this over to the center a little bit more and move this up. Now, like most of these grids, they're pretty dirty. You can see these little dark areas on here. That's just some contamination on the surface, just from being in the container. So what I'm gonna do is I'm gonna clean that all off with the ion beam, because I wanna make sure, ooh, actually there's some big contamination there, okay. I wanna make sure that it's nice and clean for good attachment. What we're gonna do is go up to 30 nanoamps, and you should start to see some ion orientation in the copper grid. Okay, I'm gonna focus. And I've got a big wad of something right where I want to attach my sample. Let's go ahead and move over. I want to see if the other one is cleaner. Yeah, it's cleaner where I want it to be. Okay, so let's do it that way. because I'm gonna set my sample right in this notch right here. Okay, so I'm gonna let that clean a little bit. I'm also going to make a slight notch, okay? So I've got a metal parameter here. I want this to be about as wide as my sample, so I'm gonna make this about 20 microns. Y, I'll adjust right now. Depth, we'll make it 10 or something like that. So it's not a lot. It says 4 minutes because this is kind of big here, but I'm just gonna bring it down here and bring it just to that little, so 2 minutes. So overall, 2 minutes is not a lot of time. And what that's gonna do is just make that notch. Like I said, once you get to this point, you've probably spent 2 hours. 2 minutes is not that big of a deal. It just holds the sample a little bit more securely, and that way you won't lose it. There are some people that like to do it flag style. That's fine. Most of the time, I will do it in this V notch. Okay, and that's all I'm making right there, that little area. So that little notch right there. Any questions up to this point as far as the lift out or anything? And again, this is what? So it's been an hour and a half. And a lot of that's just been because I've been talking and doing some demonstrations and stuff like that. But really, this should only take about an hour, 15 minutes, and then followed by the final thinning, which should be no more than like about a half hour or so. Okay, so that's done. Quickly switch back to my imaging current so I don't blow away my sample. Okay, and now I can send my sample back down to the eucentric position, the needle back down to the eucentric position. And now you should see it come in. Okay, I'm gonna adjust that a little bit. I want the Z to go down a little bit more. And I'm gonna bring the X over a little bit more. And again, this is up to you as far as like how you do your final placement. You can continue to use the manual controls, or you can use the computer controls. So I just prefer to use the manual controls. I'm used to it. I'm gonna line up my sample right into that notch. I want a slight little gap, right? And then I'm slowly gonna bring up the grid until it comes up. All right, and just before I hit, I'm gonna check my alignment again. Okay, it's a little bit off, but not much. come back here. And I'm gonna go ahead and touch down. And again, you should see those striations once I hit. There you go. So I know that I'm touching, all right? Let's pause. So now it's just a matter of depositing the platinum to stick it in place. So I'm gonna go with a 1 nanoamp beam. Focus and stigmate. All right, so now I'm gonna deposit a patch here. And that's gonna be platinum deposition, 2 microns. Okay, and then I'm gonna do a circle on the other side. 2 microns, about 5 micron circle. Right there. And then this one, I'm gonna bring up to about here or so. So that's about 3 minutes, 2 microns there, 2 microns there. And we're gonna do that in parallel. So again, platinum deposition, I'm going to double click to open the flow and wait for the chamber pressure to zip up. Okay, and now I can go ahead and start. And I'm gonna adjust my contrast again and just do a slight little adjustment here to make sure. So basically I'm gonna get deposition on both the bottom and right-hand side of this section and also a little bit on the bottom on the left-hand side. Is there any questions up to this point?
How do you keep track of the orientation of the sample in the grid? It looks tricky to keep alignment right.
So that just comes with practice. In fact, a lot of times, since a lot of people don't like this viewing this this way, because I'm basically bringing the needle down and the grid is on the top. So a lot of people will just rotate the image, and you can do that electronically. It's just after you do this several times, you're gonna realize, okay, well, I need to lift out when the sample's at 0 degrees tilt, I lift out and I bring it over. And depending on which way the sample's tilted, you'll know that you can use the ion beam to adjust the, to gauge how far away you are from the surface, and when you can use which beam to do your X and Y adjustment, okay? If you don't like using, looking at it like this, like I said, there's a lot of, after this is done, I'll rotate the image and I'll show you. Most instruments will have it. Some people just prefer to look at it, basically the grid at the bottom and then the sample coming down. But really, as soon as you get used to doing a bunch of these, it'll be, habit. What was the other question?
Why is the tilt in the ion beam window is 0 degree? Are you not at 52 degree with respect to the ion beam?
So the sample is tilted at 0, okay? And that's why we're seeing this side view with the ion beam, okay? So let me see, what's a good way to do it? Here's the mouse, okay? So this top side, that's the platinum deposition. So I'm at 0 degrees. The reason that we're seeing the side of the grid and we're able to attach the side is that now our ion beam is at 52 degrees. So we can now actually attach here and here. If I was tilted 52 degrees to the ion beam, I'd be looking straight down and I wouldn't be able to attach on the bottoms here anymore, okay? So it's just a matter of getting used to, which beam you're using to deposit and also the geometry. But after you do it a couple of times, it's not like you just, it'll be easy. It's like driving. After a while, you just really don't think about it. Okay, So now it's done. I'm gonna hide my samples, just take a quick snapshot. Good deposition there. If I look over at my electron beam, good deposition over there. So now it's time to cut away the sample, okay? I have to wait for this to recover. What I'm gonna do is I'm going to go back to serial, I'm gonna get rid of this, and I'm gonna turn this pattern into a cutting routine. Let's say silicon. I'm gonna make it into this very thin little section. And then when you go to the corners here, you get those little, here, let's see if I can do it here. That won't let me do it here. Okay. But you basically are gonna rotate the section. So you can put it right over there. And notice that I'm not cutting off the needle. Okay, a lot of people make the mistake of trying to cut off a big section of the needle. The one thing I'll do is it'll just shorten the life of your needle quite a bit, and it's also gonna take a lot longer to cut away. So what you wanna do is you wanna just make it so it's just cutting on the deposited platinum that you have, okay? So once that's done, you just hit run. And you wanna make absolutely sure that you're completely cut away here. You can change the contrast here before you move that needle away, otherwise you're gonna yank your sample off. Okay, so now you can kind of see that little waviness and stuff, kind of lets me know that I'm removed. I still see kind of a little bit of a filament here, so I'm gonna wait to make absolutely sure that I see basically dark going across there. Okay, so now it's very clear that it's cut away. So I'm gonna go ahead and stop it here. Let's go back to the 5, change that back to our ion image. This is our electron beam image. The other thing that you can see, I'm gonna slow this up a little bit more, is if you notice, the needle itself is kind of shaky. You can see that it's kind of, so that's another clear indication that it's cut away. It's also kind of like moved off from where the section was. So all I'm gonna do is I'm going to go counterclockwise with my Z. And then I'm gonna move my needle back to the park position. Go a little bit faster there. And also I'm gonna remove my platinum needle. And typically right now I would go into thinning down my sample so I can take my platinum and make it cold again, because I'm not gonna be depositing any more platinum. I'm just gonna wait for the needle to get to the park position. Okay, and once it's there, I can go ahead and take it out. And now it's just a matter of tilting up to the, I'm gonna bring this back up until it's in focus. And then tilt to 52. It should be close to eccentric. That's the center. I'm adjusting the Z knob right now. Okay, and there you have it. Okay, so this took hour 45 minutes, and it really shouldn't have taken that long. Like I said, there's been a lot of discussion, stuff like that. And you notice, again, with the fib, there is a lot of downtime. So, you know, you can actually go and check emails or do whatever you need to do.